Okay, now that we've learned how to factor using the rule difference of perfect squares, I have to warn you all. Don't jump the gun and think if you see a binomial, connect it with a subtraction symbol, that means you're automatically going to do that rule. Remember, we have a list of 5 rules of factoring, and I have them written in your notes in a specific order because that's how I want you to memorize them. That's how you're going to proceed. The first rule of factoring is always GCF. So it's very important when you're told to factor, the first thing you do is look at the expression and see, is there something in common I can divide out of all the terms? If you can, you must do that first. So if you look at your PowerPoint at your expression, it's 3x squared minus 27y squared. Most of you are going to jump the gun and say that's a difference of perfect squares, and you're wrong. Yes, it does have the difference sign, the subtraction. Yes, x squared and y squared are perfect squares because they have even exponents. But everybody, 3 and 27 are not perfect square numbers. If you memorize your list of perfect squares, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, blah, 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 blah. I didn't say 3 or 27 because there is no number times itself that makes 3. There is no number times itself that makes 27. So you can't do DPS. You cannot do the rule difference of perfect squares. What you have to do is say, wait a minute, is there a GCF in common? Sure there is. I could take 3x squared and 27y squared and divide both of those terms by the number 3. So I'm going to pull out the 3 and write it in front, and I'm going to put one set of parentheses to tell me what's left. Don't put 2 sets. When you do the GCF rule, you put the GCF in front and one set of parentheses to tell me what's left when I divide. So 3x squared divided by 3 is x squared. Negative 27y squared divided by 3 is negative 9y squared. Everybody's good? Great. But you're not done factoring. After you pull out a GCF, then look inside the parentheses to see if you have another rule. Inside the parentheses, you still have 2 terms. They're still connected by subtraction, which makes me think maybe it's difference of perfect squares. Let's check. X squared and y squared are still perfect squares because they have even exponents. But now your coefficients are 1 and 9, and they are on the perfect square list. 1, 4, 9, 16. I said them. So now I could take that parenthesis and break it down by factoring it. X squared minus 9y squared is going to factor into 2 binomials, and you're going to do difference of perfect squares. So what times itself is x squared? That would be x times x. What times itself is 9y squared? That would be 3y times 3y. The difference sign means subtract. Subtract means the signs are different when you factor. I always give the first parentheses the positive, the second parentheses the negative. Now, when you write the final answer in factored form, do not forget about the 3, the GCF you pulled out in the beginning. You write the GCF first. You do not write x squared minus 9y squared. You broke that parenthesis down to be x plus 3y and x minus 3y. So your final expression factored should be 3, x plus 3y, x minus 3y. Check yourself. If you multiply that all back out, you should get back to your original expression. All right, let's go to the whiteboard and try a couple of more.